Good afternoon. Hello everyone. Yesterday I have introduced few concepts related to TSQL. Yesterday I was explaining about various operators we used with the TSQL programming language. We have seen arithmetic, we have seen logical operators, we have seen relational operators, and we have seen even bitwise operators. Okay, so these we use very much with TSQL programming. Whenever we would like to write any procedure or function, so in such cases we use these operators. Even sometimes we use them in queries. When you write SQL queries, at the time also we use them. Okay, so yesterday we saw these different operators and how to use also have shown example along with the if condition. So whenever we work with TSQL, we can write small code blocks called as either functions or triggers or procedures, or it can be okay. So we write actually small code blocks in TSQL. In TSQL we write very small program code blocks that's called as here a stored procedure or a stored function, or it can be trigger. These kind of things we write using TSQL. So TSQL is actually a programming language like normal programming languages, but this is only meant for interacting with the database. We cannot use for other purpose TSQL. So SQL Server's proprietary programming language is TSQL. Okay, so in our discussion yesterday we discussed it about local variables, that all local variables start with at symbol followed by variable name. Then after that we should have data type like this we declare. Then followed by if you want to initialize with optional value. With some optional value you can initialize. When you want to initialize with optional value, you use here equal sign, otherwise you end here itself. Variable name followed by data type, there itself we can end, but if you would like to assign some value, so put equal symbol, then write there optional value. Okay, so this is normally the way of declaring here a variable in the TSQL. This is here exactly what local variable. Now to assign a value to that, we need to use set @variable name, followed by here you write the value, whatever type of value it is. So here in the first case, variable name data type equal to optional value. When you declare variable, at that time itself you can assign a value. You need to put here value, but this is optional. If you want to add, you can add, otherwise later on you can assign like this, set @variable name equal to value, you can write. Okay, so normally you declare variable like this, and these are called as local variables. And there is one more type of variable that is called as system variables. We have system variables in the SQL Server. They start with @ symbol. They are called as here system variables. Okay, see, my intention is first of all getting yourself familiarized with the database concepts. So once you get some hands-on experience, we can be discussing once again each and everything in detail. But initially I am trying to show you what are the features available in this, and you are going to get with a little familiarity. So you get some, your hands can become free as far as SQL Server is concerned. So you can start experimenting things. That's why I am introducing concepts one by one. I am trying to show few examples. So yesterday we started the TSQL, and further we are continuing with the TSQL today. Yesterday we have written one anonymous code block. If we recall, we have written anonymous code. So the code block does not have any name, only for ad hoc purpose have written. For the time being, the code is going to be working. Nowhere we are going to save the code permanently, only time being it is going to work. Okay, so as I told you, there are going to be two different types of variables in the SQL Server. So first one is, first type of variable is, it is a local variable, and second one is here a global variable. One is local variable, other one is here a global variable. So this is what exactly, it's a local variable, and this is going to be here a global variable. We have here two different types of variables, local as well as global. Okay, so the global variables are also called as system variables, and these are predefined. Normally we should not say them as global variables. So these are system variables, they are already defined by the SQL Server environment. You can see the few global variables here. When you expand databases, okay, you can choose any database, everywhere they are available. I expand like this first DB database, then here, so go to programmability, go to functions, and here you can go into the, whenever you expand here, scalar valued functions, let me expand this, they are not available. Okay, so here similarly we expand system functions. In the system functions you can get, if you come to aggregate functions, you cannot have any global variable, but when you go with configuration functions, there are many available for us. Date first, dbts, language id, language, log timeout, maximum connections, maximum precision, nest level, text size, version, service name, server name. So like this, these are called as global variables. These are called as here global variables. So we use like this here the global variables. These are actually the global variables available for us. So here date first we have dbts, similarly here SPID, so process ID, that is service name, server name. So these are going to be few system variables available. We cannot actually redefine them, just we can use, even we cannot assign any value to the system variables. You cannot add any variables to that particular thing, you cannot add any values to that. Therefore these are predefined variables, we need to use them. For us they are going to be looking like here read only. So now come to here new query. So it is going to open query analyzer window. In the query analyzer window, let us try to here put some. So the query analyzer window, now I would like to experiment it. So here first of all I want to see what exactly edit server name is going to give. Here just put print followed by edit server name. So when you give this, probably this may give error. Before that you need to open the database, use followed by first DB. We open this way the database, use first DB, we open this. After that we try to print the value, we try to get the value of the edit server name. Okay, select it, then execute. When we select and execute, this is going to give us, here it's giving actually the server name. Physical hardware name is here Aladi-PC computer name. SQL Express 2008 is going to be instance name. So this is nothing but copy of SQL Server, that is 2008 or to SQL Server copy we have there. So when you write there, when you print that, it's giving Aladi-PC SQL Express 2008. Now similarly, we try to get the service name. What do we get? See in that print edit service name. We write like this here. Service name we are going to type here. So what it gives, let us see. Go to execute now. It's giving actually SQL Express 2008. Service name is SQL Express 2008. Server name is here. This is Aladi-PC. It is SQL Express 2008. In the server you have both computer name and the service name. But whenever you just go for service name, it's only here SQL Express 2008. So server is combination of the computer name and the service name, but as far as service name is concerned, it gives only service name. There is no computer name in that. So like this, these are nothing but system variables. We can call them as system variables. System variables start with @ symbol, but whatever variable we define, they are going to be starting with @ symbol. Okay, so one more program I am trying to show you today. I am going to show you one more program, and I am going to use few predefined functions also in that. SQL Server supports actually different types of functions. You have numeric functions, we have string functions, we have datetime functions. Okay, so we have even some other functions also in that. We can look into what are the different types of functions available for us. See, date and time functions, cursor functions, mathematical functions, metadata functions, row set functions, security functions, string functions. All these are going to be different types of functions we use. A function is nothing but predefined code block that is saved in the SQL Server. So these can be called as even library of functions. Often programmers need these kind of functions. They are going to assist programmer very much. So with the help of those functions, we can really, within no time, we can be developing required applications. So you take any language, along with the language you have that library. So here also we have such libraries. With this also we have such libraries. So therefore here, datetime functions, mathematical functions, metadata functions, then row set functions, string functions, all these are available. We can use them. First of all, look into few mathematical functions. Let me show you the few mathematical functions in this. All these are actually predefined functions. We have here predefined functions like abs, acos, asine. So like this we have here. All these are nothing but predefined functions available for us. So every function you can use this way. Function name is abs. This gives you absolute value. Okay. So you need to give a numeric value here. Exact numeric value or approximate value when you give. So that's going to be giving you the absolute value. So this is going to be something like this. Here see print followed by abs. I put like abs followed by here 35.56. When I give, this gives us 34.56. But when I put here minus, it is going to give actually plus 34.56. Okay, so this is giving us actually absolute value. abs function is available even in other languages. In the same manner, it's working for us here also. abs minus 34.56, when you say, it is actually converting this into, it's going to convert this into say positive number, and it's printing here for us. It's printing that way. So this is exactly what print abs minus 34.56. It's giving us actually here 34.56. This is giving us always absolute value. So abs requires actually exact numbers or approximate numbers. You take float values. Float values are going to be they are going to be approximate. Okay, but integers are going to be exact numbers. You can pass exact number or you can pass approximate numbers. Similarly, we have here floor function, then similarly power function, radians, rand. So here round function, sine function, these are available. Let us try to explore those. Next thing is here, these are related to trigonometry, a sin, a tan, a tan 2, like this. Let us look into ceiling function. Let us go with the ceiling. Print followed by here we use ceiling. Then here we pass the some number we pass. We pass something like 34.56. So what value we get? See in this now. Whenever you take ceiling here, the parameters are going to be only one number. Either it is going to be exact numeric value or approximate numeric value. Now here this is going to give us 35. When you say ceiling, this is going to give us a 35 value. It's giving 35. Suppose you put here minus 34.56. What will happen? See in this. Okay, so execute this. This gives actually minus 34. Minus 34.56 is going to give us minus 34. Okay, but when you use floor function, it gives actually 35 for us. Let us do with the floor also. So print floor followed by here we type minus 34.56. This gives us here 35. When you go with ceiling, it's giving minus 34.56. But when you work with floor, it's going to give us actually here 35. Okay, so what is happening here? You look at the number. The 34.56 is in between minus 35 and minus 34. So minus 34 is greater than minus 35. Therefore, when you go with ceiling, it's going to give you minus 34. Okay, but whenever you work with floor here, floor means what? Minimum it's going to give you. In the case of ceiling, maximum it's going to give you. The range for the, if you are trying to look at the integers, so range, the minus 34.56 is lying in between minus 35 and minus 34. So lower boundary is minus 35, upper boundary is minus 34. So here next thing is what's happening here. When you go with floor, so it's taking lower boundary there, minus 35 you get. But when you go with ceiling, it's going to give you minus 34 there, like that it works. But when you take them here as positive numbers, what happens? See, print ceiling, then here we put 34.56, this gives you 35 this time. It's going to give us 35 value, it's going to give you 35. Okay, so here similarly if we go with the floor, here it is print followed by floor, then give here 34.56, you get here in this example the result as 34. Like this you can use the floor function. One is ceiling function, other one is floor function. So using floor function we get there only 34, but the ceiling function we get 35. Like this library, this is working for us. Now similarly we go with power, or we can go with the pi. In the case of pi, it's going to give you pi value. Expand this, what parameters are required? None. It's going to return a float value. That means what? When you look at when you try to print the value of pi, that gives you approximate value, not exact value. We don't get exact value in such cases. Here write print followed by use pi like this. What happens? See now with this. Execute this. This gives you 3.14159. It's giving here. So further it can go after that. To any extent it can go, because this is an irrational number. Pi is nothing but irrational number, so it's endless. Therefore it's giving approximate value 3.14159. that way we get. So this is exactly what it is, pi. Okay, so this is like constant, it's available. You can use it in number of areas. In finding out area of the circle, or in finding out perimeter of the circle, we use the pi. So using pi only we find out the area as well as perimeter. Next one is here power function. You can have a power function, do like this, print followed by power, and here you need to get power. So whenever you want to use power function, you need to pass parameters like this. Parameters are going to be the expression, exact or approximate numeric. Here this also exact numeric or approximate numeric you can use. Now suppose you want to raise phi 2 times. Phi 2 you can put, this gives you here 25 value. It's as good as finding out square. It's giving 25. Similarly we take print here, then write power followed by, this is some 11, and 3 times you have to raise it. 11 11s are 121, 121 11s, how much it is, that value you are going to get in this. So this is going to give us 11 raised 3 times. It's giving 1331. So this way here we are going to get. We are getting it as actually 1331. So this is what exactly power of 11. I mean how many times you are raising it? 3 times. When you raise like this we get. So this requires actually 2 parameters. The first parameter can be exact or it can be approximate. That means it can be integer, it can be floating point number. Similarly second parameter also, it can be exact number or it can be approximate number. We take like that. Next thing is here radians. Okay, so here in the case of radians, when you pass degrees, it's going to be converting that into radians. So whenever you pass degrees, it's going to be converting that into radians. So we have to pass here numeric value, either it can be exact or this can be approximate. Now try to print here, print, write radians, followed by we pass here degrees. We are going to pass actually degrees in this. So when you pass degrees, what happens? See there, I want to give here some 80 degrees. So when you take 80 degrees, when you convert into radians, what do we get? See in this, it's giving 1 degree. Is it 1 degree? So sorry, 1 radian we are getting here. Print radians of 80 is 1, it's giving us. Okay, suppose you give here 80.0, what happens? See now in this 80.0 I am giving here. So what do we get? This time we are taking actually approximate value. It's giving here 1.39. It's going to give actually 1.39. So it's going to be returning the type of data. So whatever type of data you specify here, same type of data will be returned here. So same type of data will be getting returned here. Like that, this is working here. So using radians, you can be finding out here. You can convert the given degrees into radians. Similarly, we go with this way, print. Then here once again radians, and give here 45.0. So what happens, see. So here we are specifying only degrees, we are not specifying minutes and seconds. Now execute this. It's giving 0.785 this way. So whenever you convert 45 degrees into radians, it's going to be 0.785, that value we get. So like this, we are actually using the radians function. Radians can convert the given, expression. It can be exact number or it can be approximate number into here the radians. Okay, so in trigonometry we require this very much. Now next thing is rand function. You have a function called as rand. With the help of that you can generate a random value. A random value can be generated. If you want to give any seed value, you can give seed value. Okay, so here let us use rand. So the seed value can be only integer. If you want to give integer, you can give that. Now here you can write this way, print, this is rand. Just we are calling the random function here. Using this you can get a random value. This is going to be in between, so this is going to be actually in between here 0 and 1. This is returning for us here a value between 0 and 1. 0.838921, we get the value that way. Now next time we use like this print followed by rand function, and here we specify say some 100. What happens, see now, when we give 100, what it's going to give, see in this. It's giving us 0.715437. So we have given here seed value is 100 here. So 0.715437 it's giving. Let us give only 1 in this. So what do we get in the case of 1? Let us see here in this. This one is also giving actually 0.713592. Okay, so we give a seed value. So we are going to give a seed value. This is going to be returning here a. Here it's giving actually a float value for us. Okay, so next function, here it is round function. The given number can be rounded up here. So we can round up here the approximate number into, we can round it up. Now here write print, I want to round up something. Print here round I use, then I would like to specify here some value 23.45 I have here. I want to round it up to 4523. This is the number I have. I want to round it up to 2 digits after decimal point. I can give like this. So therefore this gives us here 23.45. Execute this. This is giving us 23.45. You get that value. Similarly, we use like this print round it is, then here 23.45, this is 23 followed by here 0 up to 0 decimal points. I want to round it up. Now just execute this. What do I get? See, it's giving 23.00. But here whenever, if it is something like this, print round we take here followed by 23 point, instead of having 4 5 5 4 I put here 2 3. So what result we get? See now in this. So this time it's going to return for us, followed by here we give a 0. Up to 0 decimal points we want to round it up. Execute this gives 24. So like this round is going to be working. Round function is working. This way it is going to be rounding up numbers. It's going to be rounding up numbers. So here we use the round in that way. Next function is going to be sign. Okay, so you are going to get here a sign. Now let me here try what exactly it gives. Print followed by here sign, then here write say 20.45. so what it's going to be returning, see. Now here execute this, it is giving actually 1.00 for us. Okay, minus 20 I give here, what do I get, see. This is giving actually minus 1.00. So here with sign, if it is negative, it's returning minus 1. If it is positive, it's giving plus 1. And whenever it is some 0, it should be returning 0 for us. Here see print, followed by here sign, then we put here 0. What sign we get? Let us see in this. It's giving 0. That means neither 0 is neither positive nor negative. So therefore it's returning 0. But whenever you give any negative number, it gives minus 1. So whenever you give positive number, it's going to give you positive only. Once again see print followed by here sign. Now put here 23.45. Depending on the type of data, it's going to be returning. In the first case, this is what floating point number, so therefore minus 1. In the next case, it is actually an integer, so it returns 0. In the third case, 23.45 we have taken, it's going to print plus 1.0. Now similarly see here, print sign here, followed by just give 100 here, it gives for us plus 1. Similarly print we take here, then sign, followed by here, once again we use minus 100, this should be giving minus 1. So let us check this, how these are going to be working. Now see, whenever it is minus 20.45, it gives us minus 1, because here we are passing floating point data, it gives us floating point data only in that. So since we pass with the floating point data, we are getting floating point data there. Now next is what here we are passing integer, it's returning integer data. When you pass here 23.45, it's returning for us a 1.00 we are getting. When you pass 100, you get 1. When you pass minus 100, you get minus 1. So like this, the sign function is working. Sign function is working that way. Similarly, we have here a sign function. Then you have sqrt function. You have sqrt function, with the help of that you can find out square root. Here take print sqrt, followed by here you give any. See here, you can pass some parameter. This gives here for us 5. This is going to give actually 5. If you give here 25.0, what happens? See now the result is going to be 5.0. So 5 only we are getting in this. Sorry. So 25.0 when you give, it's going to be 5 for us. Like this is giving actually the square root of the given number. Similarly, we have a square function. Using that, you can actually square the given number. Give now 5, this gives actually 25. This is going to give us 25. Like this, these are working. These are few mathematical functions we can use. There are certain advanced functions like log 10, similarly log. So seldom these are used in the SQL server. These are not going to be any mathematical. Say these are not related to mathematics. We don't do any scientific applications with SQL server. Therefore, they may not be much useful here. Mostly we use these system variables which start with at, like date first, dbts, language id, language, service name, text size, version. So these you use maximum connections, how many are allowed, maximum precision, what it is, you can actually find out with them. Okay, just try to explore all these things. We don't have enough time to discuss each and everything in detail, so just try to explore what these are meant for. Okay, so why these are used practically, when we use, you can find out them. So just explore them, you find out. Now next type of functions are going to be here date time functions. Let us look into date and time functions. Okay, these are what configuration functions and mathematical functions we have seen. Next functions are going to be date and time functions. So using current timestamp, you can get current date and time. You don't pass any parameters to this. It returns just date and time. Current date time you can get using current timestamp. So here current timestamp function can give us current date and time. Just take print command, write here current timestamp. This can give you current date and time. You can get current date and time, just go with this and print it. It's giving us here 17th May 2016, 4:32 p.m. As per IST we got it. IST time we got, this gives you current date and time. Now similarly we have a date add function. Using date add function you can be adding here two dates. So not two dates, to the date you can add number of years or number of days or number of months you can add. Date part can be here a year, a month or a day, or it can be hours, it can be minutes, it can be seconds. So by how much you want to increment, and expression is going to be in date and time. Okay, so suppose, see you have today's date. So today's date you have like this. Okay, today's date today, fine. Now you can add some years to today's date, then you can get a new date. So just write here print, followed by here we use date add function. Date add function we use, then followed by date part we have to use. Date part, as I told you, either it can be year or month or day, or it can be hour, minutes and second. Now give the current date and time. Here give date time. So what it's going to be printing for us in such cases, and here second parameter is going to be 2 years. You should give here 2 years. We are going to add years. By how much you want to increment? By 2 I want to increment. Then date time when I give, it should give me a date and time after 2 years what that is going to be. You need to get that. Now just execute this. You can get, sorry, we don't have anything like date time here. This should be get date. Using get date you can get current date and time, or you can use current timestamp. Either you can use current timestamp or you can use get date function. That can give you get date, can give you current date and time. So this is 17th May 2018, 4:34 p.m. you get. After 2 years, what day it is, it's printing here for us. Print date add, year component we put here to get date. So this is exactly what date part, whether it is year or month or day, whatever it is, you get. Now let us add with the month. What will happen? See, we are going to just add month in this. What will happen? Just see in this. In the place of year, I try to use a month. We put month and we add here get date. So after 2 months, what is the date? It's giving like this, July 17, 2016. It's giving July 17, 2016 like this. Now similarly, this is what exactly month. Next one is going to be here, day we use. So this is 17th today, after 2 days it should be 19th. We should get 19th in such cases. Now select it, then execute. It gives us 19th May. So therefore, using date add function, you can be adding here the you can actually increment the date by year, by month, by day, by hour, by minute, or by second. So every time you should use actually the incrementation part. Similarly, you can use even negative values. I can put here -2. What happens? See, it should give us today it's 17. It should give 15th. Should be giving it, this one should give us 15th now, because we are keeping there -2. Incrementation is what? By 2 we need to increment that. So therefore it's giving here 15th May 2016. So like this we can use date add function. There is a function called date add function. With the help of that we find out this one here. So similarly we have a date difference. When you look at the date difference, you see the parameters. We have the first one is date part. You have starting date, you have ending date. Okay, so this can be giving us here date and time. Again you are going to get. Okay, we can take here we are going to take date part is going to be similar to the year or month or day. We can specify there. So we are going to specify that. Like here, how we specify date part in the same manner, we need to specify here. Then followed by starting date we give, ending date we give, and that's going to be returning date and time for us. Now here, let us do with that. We have a starting date, we have ending date, then it's going to be returning for us date and time. Okay, we specify a starting date, we specify ending date, and try to see the difference now. Here write print followed by date diff. We use like this. Date diff we put date part is here year. Starting date I give like this. Here this is 10, then 10. This is 2010 followed by ending date I need to specify. So ending date is going to be, now this time I use here 05, then 17, then this is 2016. Like this I specify. Like this I am going to specify what this is going to print for us. See in this, it's giving us actually 6 for us. It's going to give 6. Here how many years difference it is? It's giving 6 years difference it is giving. Now suppose in this if you give month, what happens? See now in that, take this and try to put here a month. How many months exactly in between these two date times it can give us? Now select and execute. When you select and execute, this gives us actually how many months it is. It is 67 months we get now in this. It's up to 67 months. It's giving us actually 67 months in this example. It's giving actually 67 months for us. Date diff this is. With the help of that, you can find out the difference between the two given dates. Starting date you have, ending date. So this is exactly date diff. In the first case we are adding two dates, not two dates. We take one date, to that we add year, we add month, or we add days. Similarly you can experiment with hour, minutes and second. Now here in the case of date difference, exactly what difference you want to get? Difference you want to get in years or months or in days or in hours or in minutes or in seconds. You can calculate that. You need to specify starting date and you need to specify ending date. So here this is the starting date and this is the latest date. Between these two, how much time, how many years difference are there you can find. Similarly with months also you can find in the same manner. Next one is here. This is the date diff function. Okay. Now here next one is date part. You can find out the date part of the given date time. You can find here date part. So date you are going to get actually, first of all you take date name. Date name we take here. We put the date part and expression followed by here. It should be giving the date name. For example, this year's current month we have to get like May. Today's date you have to get like actually Tuesday. So therefore here you print this way, here print followed by date name, then here specify first of all the date part. The date part is here month. The next thing is here expression. We take get date. This can give you current date and time. Now from this we should get the date name. Select and execute. This gives us May. It's giving actually month name for us in this. Similarly, we go with the print here, then say date name, then followed by here we want to get day and get date. Like this you give here. What result we get? See. It's giving 17th. You are getting actually 17 here. It's giving the day. Suppose you want to get character day. For that we do like this: print date name, followed by here character day of week, day of the week. WD we use here, or weekday we specify here like this. We can put weekday, then followed by right here get date. Now just check this, what we get now from this. Execute it. It's giving us Tuesday. This today is in fact Tuesday, so we get Tuesday like this. Using date name you can get in the string format. Month is going to be May, names you are getting. So for day you are getting here date name, if say weekday, get date, this is giving Tuesday. So like this you can use here date name function. This is returning here varchar. Similarly using date part. So with date part what we can get, see, print, this is going to give only integer for us. Date part, followed by here we specify month. Okay, then here write get date. What happens now, see with this. Okay, this should give us a 5 value. It's giving 5 because 5th month it is. Similarly take print, then here put date part, then here specify year and say get date. Get date can give you current date and time. So now when you invoke this, it should give us here 2016. This is giving actually the year part. Okay, similarly we can get day also in this. Go with the print, then date part, then specify here day, then write here get date. So when you take like this here, you are going to get in this 17 we get. Now similarly use like this print, then here date part we use followed by here, this is we say weekday, followed by get date, we give like this. So what value we get now in this, let us see. Execute this, it gives 3 because the weekday starts with Sunday. Sunday is the first day, Monday is the second, 2, and Tuesday is going to be third. So this is third day of the week. Therefore we get this as here 3. We are getting this one as here 3. So first one is what? Sunday is 1, Monday is 2, Tuesday is going to be 3. Like this you can convert them into numbers and show here. So like this you can be using date part. Even this also will be useful very much. Similarly we can use here day. Using day you can get current date. Parameters are going to be expression in date time. Okay. Similarly if you look at get date here, this can be giving you current date and time. It can give you current date and time. Right now what is the date and time it can give you. So similarly we have a function called as isDate. With the help of that, whether the expression is a date expression or not, you can find. So look into these things also. Take print, followed by here, write here day, then say current timestamp we take. Current timestamp. Put like this. So this should be returning for us the day from the current date and time. It should be 17. It's giving 17 because current timestamp can be here today's date and time. Right now what is the time and today's date it's going to take. Therefore from that when you retrieve day it's going to be 17. Similarly we had here month. Month also we can get same thing. It's going to give you month. Now here isDate. We can use here isDate function. Print followed by here write isDate. We write like this. Then here we try to specify some day. the day is, I put something like this 20, then followed by 2016, like this I put. This is invalid month. In fact, this is going to be invalid month. Reason, you cannot have any 20th month. I specified in the MMDD by notation. So when I give first one as 20, this is going to become invalid date. So therefore it says false. 0 it is saying. That means what? It is going to be false. But when you put here something like 10, that is going to be 1 for us. When it is 1, that is going to be a true value. When it is 0, it is false. You need to assume like that. 10/10/2016 is valid, but when you put here 20/10/2016, that is going to be wrong, because month cannot be equal to 20. You cannot have 20th month. If you try to specify 20th month, that is going to be totally wrong. Okay, so therefore here print is date 10/10/2016, you get actually wrong result in that. But when you put here 10/20, this can be correct result. This is going to be here a correct result for us, because you can have actually 20th day in that. This is one only. If you put something like 35 here, what happens? See now, I put 55. You can't have any 55th day, therefore this should give us 0 value, because this is invalid date. What we specified is invalid date, therefore it cannot give you a 1 value. It can give you only true, only 0 in that. Okay, similarly you can use here the month function, and one more thing is year also we can get from that. So you can use month function, you can use year function. Using month, you can be finding out the month of the given date and time. With year also you can be finding out the year of the given date and time. Just like day, you can use it. Okay, so these are actually date related functions. Now based on this, we need to write some simple programs, TSQL programs we need to write. Based on the mathematical functions and based on the date time, we need to write. Okay, but before that, in the TSQL, yesterday we saw how to declare variable, how to set values. Okay, TSQL supports save data types like SQL Server. In the SQL Server data types, whatever types we have, in the TSQL programming also, you can use same. Exact numbers, approximate numbers, date and time, then bit values we can use, floating point numbers we can use, like decimal, double, then say numeric, then float. Okay, all these you can use. Similarly, you can be using varchar, nchar, nvarchar. Okay, so varchar max, this all you can use. Character type of data also you can use. Unique identifier you can use. So all these are possible. Whatever are available in the SQL Server data type, same you can use with the TSQL. Now here I would like to introduce you one more programming construct called as if condition. So using if condition, you can be checking for the you can control the flow of the program. If the given condition is true, the certain code block is going to be getting executed, but when the condition is false, some other code block can be getting executed. Whenever you take any program's control flow, that's going to be in 3 different ways. One is sequential flow, second thing is selectional, third one is iterative. So if it is sequential, one after another statements they get executed. If it is selectional, depending on the condition, the control may be getting branched off. So in the case of the iteration, so it is going to be getting repeated. Code blocks are going to be getting executed repeatedly for specified as long as the given condition is met. So today we are going to look first of all into if condition. How to use if condition? See here. If condition is written like this. Here we have a if condition followed by, we have here the Boolean expression. We put here Boolean expression. That means this can be returning a true value or false value, that is Boolean expression. Followed by, you can write here statement. If it is one statement, you don't require any begin and end. But when you have more than one statement, you should use actually begin, then followed by here statement 1, then statement 2, like this probably you write it. Then at the end of this you require here end. Okay. After that, suppose when expression is returning a true value, you want to execute some piece of code, you write like this. Even when that is false, in such case also if you have to execute some piece of code, else you need to put else there. Then here in the else again you can write a begin statement and end statement. In between begin and end you can write here statement again. statement 3, then statement 4, this way you can set it. So statement 4 you can write like this. Whenever the condition is returning a true value, this part of the code will be getting executed. When condition becomes false, this part of code is going to be getting executed. So else meaning is what here? When this is false, the else code block will be getting executed. So using begin and end, you are going to form here compound statements. Compound statement is a statement which contains number of individual statements inside that. Number of individual statements you have, that is called as a compound statement. We have here compound statements if condition is true or false. If it is true, you go to here this part, statement 1, statement 2 you can execute. But when the condition is returning a false value, you go to this here, statement 3 and statement 4 will be executed. Like this is going to be working. We have if condition followed by an expression. This can be returning a true or false value. Depending on the true value, this part will be getting executed. If it is false, this else part will be getting executed. Like this we can use the if condition. Here see, using begin and end are not compulsory. If there is only one statement which you have to execute when the condition is becoming true, therefore if it is only one statement, you don't require begin and end. But when you have bunch of statements, if you have to execute together, then in such cases definitely we need to unite them with the help of the begin and end. You should make them as a compound statement. So like that you need to write. And else is also always not mandatory. If you need, then you can use it, otherwise just you can omit. Now here, using this if condition, I want to write a program. So the program here is going to, it's going to take some age. It's going to take some age. So when age is greater than or equal to 18, it should print the candidate is eligible. Otherwise, it should print the candidate is not eligible. So like that, we need to write now some piece of code here. Okay, so let us try to create some anonymous code block. I am trying to create here some anonymous code block. Based on that, I can actually find out whether the candidate is eligible to cast his vote or not. That means whether they can exercise voting right or not. So to cast a person's vote, the person should have minimum 18 years of age. So without having 18 years of age, they cannot exercise their voting right. So for that now I am going to write code. So first of all I write like this, declare, this is what @age. @age I write here float, like this I am going to write here. I am going to write this as actually float. Okay, so I am going to use this as, instead of using float I put like integer here, this one. This is going to be integer. Then here I write set @age equal to, here I need to assign some value. I have a random function using random, I can be assigning there some value. Now here write set @age equal to, I use rand function, then multiply this with the 100. You can get up to 99 years with this. So set @age equal to rand multiplied with 100, this can give a value between 0 and 99. Now you need to use the if condition like this. If we use if @age greater than or equal to 18, here we print this way, print here a person who has an age greater than or equal to, put like this here, okay, with an age, a person with an age now here we need to take the age, we have to convert them, put like this, because there is a number, we need to use here varchar with that we can convert. Yesterday we saw this function, how we can use it, @age, then here write, put a plus here, then write here is eligible to cast vote. Like this we can set it. This is exactly age. Else what we write here? So else here we write this way, write like this, print a person with an age, put plus here, again convert it, convert, then varchar comma @age, put plus here, is not eligible, not eligible to cast vote. Like this I have written some piece of code. This code now I would like to execute. I am declaring a variable called as here age. This is nothing but integer data. We are setting age equal to rand multiplied with 100. So you have a value between 0 and 99. Whenever age is greater than or equal to 18, now in such cases we need to print here a person with an age. Okay, so age, what is the age we get? Some age we are going to get, that may be greater than 18. So in such cases, greater than or equal to 18, in such cases it prints it as is eligible to cast vote. Otherwise it says not eligible to cast vote. So go to this point and execute this now here. A person with an age 47 is eligible to cast vote. Once again execute. A person with an age 94 is eligible to cast vote. Like this we get. Once again execute this. It says a person with an age 0 is not eligible to cast vote. Definitely you can't have here 0 age. Therefore try to put here +1. Now in such cases you never get 0 age. So 0 age meaning is what? The person is not born at all. Like that we need to assume it. So therefore having 0 age is meaningless. Therefore make it 1. Now here a person with an age 35 is eligible to cast vote. 22 is eligible to cast vote, it's saying. 39 again is eligible. Here 77 is also eligible. Seldom you get here. You should get less than 18 years. In such cases not eligible we are going to get. Okay, so it's always giving actually higher ages, but now this time we got a person with an age 17 is not eligible to cast vote. So like this it's giving us here, it's giving this way for us. A person with an age 17 is not eligible to cast vote. Like this it's printing here, it's going to print this way. So with the help of if condition we could find. Here we are using if condition. Using if condition we are doing this. Okay, so this is called as one selection statement. This is exactly what a selection statement. So using this we exactly find out whether the user is eligible to cast vote or not. Okay, so whether candidate is eligible to cast vote or not, here we are finding out with this. We declared a variable called as age, @age, that is integer type of data. Later on we are assigning a value. What value we are assigning, that is not in our control. It's going to pick a value between 0 and 99. Then to that we are going to be adding 1. Because if it's picking 0, there is no point in that. There is no meaning for the 0 years. Person's age cannot be 0 years. 0 years meaning is what? The person is not born at all. So the person who is not born, if you try to use that age, there is no point in that. So therefore here to get actually at least minimum 1 year, I have added like that. Rand multiplied with 100, that can give you any value between 0 and 99. Suppose that is 0, in such cases you can be adding 1 to that. In any case, even if it's picking some 17, that becomes 18. If it's picking some 35, it's going to be 36. So like that we have taken some random value. With that we are printing here. So it's giving us actually if the age is greater than or equal to 18, it prints that is eligible to cast vote, otherwise not eligible to cast vote. Like this it's giving actually us the result. So this is here we are using if condition. Using if condition we could do like this. That's it for today.